Hi there, welcome to highschoolmaths.co.uk. Today we're going to be looking at the 2017 National 5 Maths paper 2, that's the calculator paper. So, question 1, find the magnitude of the vector. V, we're given the component form of the vector here, so to find the magnitude we're looking for the square root of 18 squared of each of the components squared, so plus 3 squared, and type that into the calculator. We've got 18 squared plus negative 14 squared plus 3 squared. That's 529. So it's the square root of 529. And that gives us 23. So that's the magnitude of the vector, the size of the vector, and that's what we're looking for that question. Okay, question 2. A necklace is valued at £1,200. Its value is expected to increase by 4.5% per year over the next 3 years, so it's a compound interest question. Calculate the expected value of the necklace after this time, given your answer to the nearest pound. Let's highlight that, it's quite important. We don't forget that at the end of the question. So, the value of the necklace to start off with is 100% plus the 4.5% increase, so that's 104.5%. We're going to change that to decimal. So 1.045 divided by 100, power of 3, because we're repeating it over 3 years, and we'll multiply it by the original amount of £1,200, and then type that into the calculator. We get 1.045 to the power of 3 times £1,200. That gives us £1,369 and 39.40 pence. Round. Now it did ask for the answer to nearest pound, so we're going to take that down, and that would be £1,369 to the nearest full pound. Okay, question 3. Piece of land shaped in a triangle is shown below. We're given those dimensions and the angle which are shown in the diagram. No one wishes to build a fence, so calculate the length of the fence. So we're looking for the perimeter, which means we need the side QR. Call this x here. And we've got two sides in the angle in between, which means we're using the cosine rule. So a squared equals b squared plus c squared minus 2bc cos a. A would be the angle, and b and c don't matter, so I'm just going to write over these. Small a here, b opposite side, and c opposite side. So we've got a squared equals, so b squared is 180 squared plus 250 squared minus 2 times 180 times 250 times cos of the angle, which is 147 degrees. Typing that onto the calculator is going to take a while, but do it carefully. 178 squared plus 250 squared minus, and we're doing 2 times 180 times 250 times cos 147. That should give us 170,380.35. And that's the value for a squared, so we're going to square root that answer, and that will give us 412.77 to 2 decimal places for the size of that. So we're then going to add the perimeters together, so the total perimeter all around the edges, because that's what we're looking for, would be 412.77 plus 250 plus 180, and that gives us 842.77 meters. Okay, question 4. Solve an equation giving your answer correct to 1 decimal place. So we've got a quadratic function here. If it's given, this kind of part here is hinting that we have to use the quadratic formula, which is in the formula sheet. So we've got the value of a is 2, the value of b is 5, and the value of c is negative 4. So we've got, and from the formula sheet, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're just substituting the numbers in here, so it's negative 5 plus or minus the square root of 5 squared minus 4 times 2 times negative 4 all over 2 times 2. Let's simplify that a little bit. So negative 5 plus or minus the square root of, so it's 5 squared minus, that's going to get the double negative here at this stage is going to give us a plus, so we're going to do 25 minus 4 times 2 times negative 4, and that gives us 57 all over 4. So at this stage we're going to take the plus or minus part and we're going to split it up to get our two answers. So negative 5 plus root 57 over 4, or x equals negative 5 minus root 57 all over 4. This will give us two solutions. So negative 5 plus root 57. Press the equal sign here if you've not got the dual line display, and then divide by 4. That gives you 0.637. Dot dot dot. And for this one, negative 5 minus, so negative 5 minus square root of 57. Press the equal sign again, then divide by 4. Gives us negative 3.137. Dot 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 dot. And then we'll go back to the question, just check we've got everything. So correct to one decimal place, 0.6 for one answer and negative 3.1 for the other. So we're always looking to write down the unrounded answers first here, because there is an additional mark for the rounding in this question. So we make sure we write the unrounded and then show our rounding. Okay, question 5. Theatre groups sold 4,830 tickets for the show. There's 15% more than they sold last year. How many tickets did they sell last year? Okay, so this is one of your typical kind of working backwards questions. So last year they would have sold 100% of the tickets. This year they sell 15% more. So in total they sell 115%. And what we're looking to do is get back to the original value. So to do that, we're going to divide by 115, and then which will give us 1%, then times by 100. So we take the 4,830 tickets, divide it by 115, and times by 100, and that'll take us back to that original value. So 4830 divided by 115 times 100, 4,200 tickets sold last year. Okay, question 6. So we've got a sphere, kind of chocolate caramel thing. Cross section is shown below. So we've got a sphere and the inside, the kind of white sphere, and then we've got the kind of chocolate layer on the outside. That tells us all the information here on the diagram. Coating's 3 mm, diameter of the whole thing is 24. Calculate the volume of the chocolate to 3 significant figures. Okay, so what we've got here is really two spheres. So we'll do the outer sphere first. So again, formulas in the formula sheet, 4/3 pi r cubed. So it's 4/3 times pi times the radius of the outer one, so that would be 12 cubed. And type that into a calculator. So 4 divided by 3 times pi times 12 cubed. That should be 7,238.23 millimeters cubed. The inner is the same formula because we're dealing with two spheres here, so it's 4/3 pi r cubed again, but the radius is going to be different here for the inner, kind of the white shape here. So it's 4/3 times pi times, now we've got 3 millimeters at each side, so in total we're taking 6 millimeters away from the diameter. So that leaves us with 18 for the diameter of the white section. And if we split that in half for the radius of the white section, we've got a 9 millimeter, keep writing meters, sorry, 9 millimeter radius, so times 9 cubed. And again, we just type that into a calculator, so 4 divided by 3 times pi times 9 cubed, and that should give you 3053 0.63 millimeters cubed. So the volume of the chocolate surface altogether is going to be the outer sphere minus the inner sphere that's kind of been cut out. So let's call it chocolate equals 7238.23 minus 3053.63, and we're just doing that subtraction. So 7238.23 minus so let's see, so let's try that again. 72838.23 minus 3053.63. That gives you 4184.6 millimeters cubed. And again, going back to the question, 3 significant figures. So our first significant figure is the 4, then the 1, then the 8. So we're going to round in after this point here, telling us to round down. So it's going to round to 4180 millimeters cubed for our final answer. Okay, here we've got 2 triangles placed together, and it's asking us to is the larger triangle right angled. So let's see how we're going to approach this. Okay, so let's put in the dimensions into the whole triangle here. So we've got that this is 8 centimeters, this is 19 centimeters, and the bottom side when they're joined together would be 22 centimeters. So what we're looking for is, if it is a right angled triangle, then we're hoping that this will be the right angle, because this is across from the longest side, so that would be the hypotenuse. So we're looking to do a little bit of converse Pythagoras. So we'll start off with 2 short sides, 8 squared and 19 squared. Find the sum of that. 22 squared, find the sum of that. So 8 squared plus 19 squared equals 425. 22 squared is 484. Okay, so as the larger triangle right angled, well, if it was right angled, then a squared plus b squared would equal c squared, which it doesn't in this case. So since 8 squared plus 19 squared does not equal 22 squared, this is not a right angled triangle. Okay, and that's using your converse of Pythagoras method there. Alright, moving on. Question 8. Diagram below, RQ and PQ represent vectors C and D respectively. Express PR in terms of C and D. Okay, so we're going from P to R. We've got to use the vectors C and D. So if we look at the direction of the arrows, we're going from P to Q first. So that would be the vector D plus the negative vector. So actually we're traveling on the opposite direction, so we don't need a plus there. So let's go for, so if it's the negative vector, we're going against the direction of C, so it will D minus, that will be the negative vector, so D minus C. And moving down to part B, no idea why that's not working. Okay, so moving down to part B, the line QP is extended to T, so TP equals PQ. Okay, so these two, this one and this one, are the same length. So if that's D, then this is also going to be D. V is the midpoint of PR, so this is the middle of this line here. Express TV in terms of C and D, giving you an answer in the simplest form. Okay, so let's see how we're going to get from T to V. We can't really go this direction directly because that is not going, we've not got any directional component in terms of D and C, so we've got to go all the way along here, down here, and then we're looking to go up to V. So let's have a look at how that looks. So we've got the vector T to V would be equal to D plus d plus it's negative c, because we're going against that vector again, and then it's plus a half of rp. Okay, so that's how we're getting from t to v. Now, a few problems here. I can simplify the plus negative c down to negative c. So we get 2d, so we'll rub that out first. So collect like terms, we've got 2d minus c, but we've got this plus half rp. Now, that's not particularly useful in terms of what we want. So what we want to do is look back at the question, see in the leading part for the question A, we had a vector for PR. Okay, so we knew PR is equal to D minus C. So if we want the vector RP, that would be going the opposite direction. So that would be C, positive C, and minus D. You can see that in the diagram, C minus D. So we've got an actual expression here for the vector in terms of RP. So we've got a half of C minus D. Pop that in there. And then we just have to multiply this bracket. So half of C minus a half of D. And that equals, so 2D minus a half D would be 3 halves. D negative 1c plus a half c would be negative a half c. Okay, so that would be your resultant vector. Next one, question 9. Factorise 4x squared minus 25. So we've got looking for common factor. There's no common factor there. It is only a 1 mark question. So we're looking for difference 2 squares. So it's going to go into 2 brackets. Same terms at the beginning, 2x and 2x. Same terms at the end, 5 times 5, 1 plus and 1 minus. And that's the factorised form. Then leading on to look at our algebraic fractions. So the top line, you'll notice, is the same as part A, so we can substitute our answer for part A into this, and hopefully when we factorise the bottom line as well, we'll end up with some kind of factor we can cancel. Okay, so this is a trinomial on the bottom, so we get 2x and x for our first term. We're looking for probably a 5 times 2 at the end to give us the 10. Could be 10 and 1, but it's more likely to be 5 and 2. So we're looking for which bracket we're going to put this in. If we put the 5 here and the 2 here, that would give us 5x for these two, 4x for this one, which would help with the minus 1x we want in the middle. So we want a minus 5x and a plus 4x for the outer terms to give us the minus 1x. And if we look at that, we've got 2x plus 5 and 2. Sorry, wrong one. Let's go back and undo that. So we get 2x minus 5 and 2x minus 5, so that leaves us with 2x plus 5 on top and an x plus 2 on the bottom as our final simplified fraction. Okay, question 10. We've got a little diagram showing some bearings. Dunbridge is 15 kilometres west of Aylesford. Dunbridge, the bearing of Fairtown is 126 degrees. All the information shown in the diagram. Calculate the distance between Dunbridge and Fairtown. So we're looking for this is our x. Okay, so let's find what we want here. Really is the angles of the triangle. It's telling us that Dunbridge is west of Aylesford, so that means if we've got the bearings here, this is a horizontal line. That means this has got to be 90 degrees, which leaves us 36 degrees in the triangle. Likewise here, that's 90 degrees. So if we do the full turn, 360 minus 230 minus 90, that'd be 360 minus 320, which is 40 degrees in here, and we can find the third angle in the triangle, which is really helpful. So that's 76 for those two, so that's going to lose 104 degrees for our bottom angle. Okay, so looking at this information, we've only got one side in the triangle. If we've only got one side, we've got to use the sine rule. We need at least 2 sides for any of the other cosine rules. So it's side over opposite angle, so x over sine 40 equals, and it's 15 over opposite angle, 15 over sine 104. And we're going to cross multiply, so x times sine 104 equals 15 times sine 40. We want the x on its own, so we're dividing both sides by sine 104. and that gives our missing value for x. So it's 15 times sine 104. Sorry, 15 times, let's try again, 15 times sine 40 first, and then we're dividing by sine 104, which should give us 9.94 to 2 decimal places. So 9.94 kilometres. No rounding specified in this question, so we'll leave our answer to 2 decimal places. Okay, question 11. A straight line has the equation 3x minus 5y minus 10 equals 0. Find the gradient of this line. So it's not in the form y equals mx plus c, it's in the more general form. So we're going to try and isolate the 5y term. Now the easiest way to do that is to add 5y to both sides. So if I do that, I'm going to leave the 3x and the minus 10 on the left hand side. Adding 5y to both sides gives us that expression. I can flip the whole thing just so it's a wee bit more comfortable and a wee bit more the way we're used to seeing it. And then divide everything through by 5. So we divide the 3 by 5, we get 3/5, divide the 10 by 5, we get 2. Remember, this is compared to y equals mx plus c, so the x term, the coefficient of the x term is our gradient, so m equals 3/5. Okay, moving on, question 12, express it in the form x to the power n. Okay, so we've got 1 over the cubed root of x. So that's 1 over, cubed root would be x to the power a third. Okay, the x, there's no power, so it's just a single unit term on the numerator. So x to the power of third. And if we want to write this so that it's not a fraction, we can bring the x to the power of third term up to the top and make it negative. So it's x to the power negative a third. Okay, question 13. 2 identical shapes are used to form a logo. Each shape is part of a circle. The circles have centers C1 and C2. Radius is 4. Radius of each circle is 14. Logo has half-turn symmetry about the point, midpoint of AB. AB is 48 centimeters long. Lots of information there, it's not in the diagram, so let's start adding some stuff. Calculate the height of the logo. Okay, so the height of them is going to be the same. If we find the height of one of the segments of the circle, then we will just double that to find the height of the total. Okay, so it's looking like one of these kind of Pythagoras questions. I'm going to put some information in. So it tells us A to B is 48. So that means from here to B is going to be 24. I'm just going to use the bottom circle, you can use the top one, they're identical. It tells us the radius of each circle is 14, so that's the distance from the middle to the outside is 14. And if we look at this carefully, we can make that right angle triangle. So as one of your Pythagoras questions, this distance here would be 12, because again that's half of the 24. We've got two sides of the right angle triangle, so we can call this, we'll call this L. So L squared equals, and it's the shorter side, so 14 squared minus 12 squared. L squared equals, so 14 squared minus 12 squared is 52. L equals the square root of 52, and L equals, so square root 52 is 7.21. Keep it to 2 decimal places. So that distance here is 7.21. Now, if we look at this, this distance here, 14, as the radius. This distance here is also the radius because it goes from the middle of the circle to the outside. So if this is 14, this is 14. So the height of one of these part circles is 14 plus 7.21, which is 21.21 centimeters. But that's the height of only one of them. If we're looking for the whole height of the shape, then we've got to double that. So total height be 21.21 times 2, which is 42.42 centimeters for a final answer. Okay, question 14. So it looks like we've got a kind of arcs and sectors type question here. Let's see, the radius of the circle is 7.4. The arc has a length of 31.5. So this curved part, remember the arc is the kind of curved part going around the edge. So we're talking about this part here. It's 31.5. I've just drawn in red. So calculate the size of the reflex angle AOB. So we're looking for this angle in the middle. So it's talking about arc length. So we'll use the arc length formula. It's not in the formula sheet, so it's the angle over 360 times pi d. Now it tells us the arc length is 31.5 as part of the question. It tells us the angle is what we want to find. Times pi times the diameter. So the radius is 6.4, the diameter would be all the way across, which is 12.8. We've got to rearrange this to find the value for x, so we're going to move everything over to the left hand side apart from the x, so we'll multiply both sides by 360, and we'll divide both sides by pi times 12.8, and that will get the x term on its own, which will be our angle. So let's go for that. So 31.5 times 360 divided by pi times 12.8, and that gives us 282.00. So 282.0 degrees for our final answer, and that is a reflex angle, so that looks roughly like it could be a correct answer, so that fits with the diagram. Okay, question 15, which I think is the last question in the paper, a nice little trigonometry one to finish off with. So we've got here wind turbine 3 blades is showing the height of the tip blade A above the ground, h of the tip of the blade above the ground, and each rotation is given by this formula, where x is the angle the blade A has turned clockwise from its vertical position. Okay, calculate the height of the tip of the blade after it is turned for an angle of 60 degrees. Okay, so it's just telling us, it's just asking us here to substitute in the value of x being 60 degrees. So let's go for that. So h equals 40 plus 23 cos 60 degrees. That should just give us an answer. So 40 plus 23 cos 60. That gives us 51.5. And that would be meters. Yes. Okay, so that's only a 1 mark question. Part B. Find the minimum height of the tip of blade A above the ground. Okay, so again, this one we've got to think about how the what we've got in the trig formula, and I'm going to rewrite this as 23 cos x plus 40 rather than the other way around. And if you think of your wave, if you had the wave 23 cos x, so it's a quick sketch, so we've got a sketch for cos wave, blah blah blah, it goes up to 23 and down to minus 23, but then the whole thing is shifted up 40, so it would go something like that, and it would go up to 63 because it's moved up 40, and the minimum point here would move up 40 places as well, so instead of being minus 23, that would be minus 17. My diagram's not perfect, but we'll screw that in there, minus 17. Okay, so the whole thing shifted up, sorry, 17, not minus 17. So the diagram has shifted up 40 spaces there, or 40 places, 40 units. So the minimum height of the blade would be 17. Just using that kind of formula there. Above the ground. And the, oops, so I've written that in part B, part A rather than part A, B. There we go. Okay, and final question. So we're looking here, part C, calculate the values of x for which the tip of the blade is 61 meters above the ground. So it's saying the h value this time is 61. So for part C, we've got our equation again. So here's our equation, but this time we've got 61 equals 23 cos x plus 40. So in every step, we're just been using the equation in different, the trig equation in a different way. This time we've got to solve the equation to find the two values for x, where the tip of the blade is 61 equal to 61 meters above the ground. So I'm going to write this again the more conventional way, so that the more complicated part is on the left hand side. So we're taking away 40 from both sides first, which gives us 21, and then we're dividing by 23. So that gives us 21 divided by 23. Okay, at this stage when we've got the cos x term on its own, and this will vary how you approach this part, but you've got your kind of 4-quadrant diagram, ASTC, representing the 4 quadrants, representing the sine, cos and tan graphs. And at this stage we've got cos as a positive value, so we tick the all in cos quadrants. This is 0, this is 180 in the middle, and this is 360 at the end. So what we want to do is we want to use this to get our two answers. Now we're going to get our related angle from this expression here. So the related angle is going to be inverse cos of 21 over 23. So type that into the calculator. So and so we're doing shift cos, inverse cos of our answer there. No. So it's a minus 1 of 21. Excuse me while I just mumble to myself. That should give us 65.9 degrees, we'll say. Okay, this is a related angle. That's not necessarily going to be one of the answers. Our answers have to fall between these two quadrants. So one in the 0 to 90 and one in the 270 to 360. So our first angle is in the first quadrant, that's 0 plus. And the last quadrant is the 360 minus. So we do 0 plus 65.9, which is 65.9 degrees. And we do 360 minus 65.9, which gives us 294.1 degrees. So that's our two sets of solutions, and it was asking for the values of x, at which the tip of the blade is 61 meters above the ground. So that would be the two values of x between 0 and 360. Okay, let's just double check. I think that's the last question, but let's just double check. Yes, that's us finished. So that was the 2017 National 5 paper. I hope you found that useful going through those questions. If you do have anything you want to ask in the comments, please ask below and I'll get back to you as soon as possible. Also visit the site highschoolmaths.co.uk for other videos and worksheets, and if you like the video, please don't forget to like it, subscribe to the channel and share the video if you could, please. Okay, thank you.